Alright, hi Westmont Algebra 2 teachers, this is Steve here. Just thought I'd make a quick little video tutorial of how to do regression using GeoGebra. So the first thing to do is open up your web browser, and I actually have a bookmark here for GeoGebra, right there. But in case you don't have it, this is the address for it right there. So when you first open it up, you get something that looks like this. What you probably want to do, it gives you all these different options. It kind of doesn't matter what you choose, but for our purposes, let's do spreadsheet. And it thinks for a minute. I just brought it up because I was playing with it earlier. You should get to a screen like this. I'm going to adjust the windows just a bit. We don't need all those columns there. If you need more, just pull it out. I'm just adjusting the frames so it looks nice. All right. So the first thing to do is this is just a normal spreadsheet little mini app right here. And it works just like Excel or anything like that. So I'm going to have the A column be my X values and the B column be the Y values. And just go ahead and type them in really fast. So I actually just cut and paste there because I had already saved some values from Excel. All right, so what's the next step? So we've got these numbers typed in. So what you want to do is highlight the numbers you want to use and click here on this button that kind of looks like a graph, and you get some different options. The option that we want is the two-variable regression analysis, and the picture just looks like a line of best fit on there. So you click that. And so here's what opens up. So there's this graph over here, which is a scatter plot of your points. So for example, here was 1, 2, and there's 1, 2. You get this middle frame here. I actually don't need the middle frame now. I'm going to come back to it later, but for now we're going to kind of squeeze that closed. I just want to focus on this right here. So what's the first thing you want to do? Well, the first thing you want to do is decide on what kind of model you want to do. So if you come down here, it says regression model, and right now we're set to none. But if you click it right here, it gives you these options. So let's say we want to see a linear model. So we just click on linear, and it tells you, all right, here's the line of best fit. It draws it on there for you. It gives you the equation, and it even lets you do like estimates of things using this equation. So notice I don't have an x value of 4 on here. So here's x equal 4. We don't really have in the actual data, we don't know a y, but we can use our line of best fit to get a estimate for it. So I'm going to come over here and type in 4, and when I push enter, it says, all right, the y-coordinate by plugging in x equal into this formula is 5.5269. So you can use that to get estimates pretty quickly without having to actually go to a calculator and type in those formulas. Now I can hear Adrian saying, but where's my r? Where's my r squared? So you can actually get a whole lot of data from this table. What you do is this button that's right over here, it kind of looks like a sigma sign. So that actually gives you lots of statistics based on your data. So I'm going to go ahead and click it. And it opens up this screen right here. So it tells you the mean of your x's. So that's the average of the 1, 3, 9, 6, 7, 2, and 12 is 5.7143. The mean of the y is 6.1429. Now you might ask, how does it know which is the x and which is the y? There actually is a button to control that, but the default is that the first column is the x's and the second column is the y's, and there's a way you can change that around, and that's actually using this button right here. It says switch around what you wanted for the x and the y's. Let me just quickly show you how you can use sort of the spreadsheet type features to actually compute this mean manually. So I'm going to come back over here to my spreadsheet, and let's say I just want to add up all these things here. So I'm just going to highlight them and then push this button right here. So this button gives you all kinds of options you can do. You could actually go right to mean, and you'll see it's 5.7, but let's actually drill down a little bit deeper than that. So first I'll do is I'll just compute the sum. So it says the sum of those numbers is 40. And so when you add up the numbers, you have to divide by the number of numbers you had. So we have 7 numbers on here. I know it maybe looks like 8, but that number is actually just the sum right there. But in our original data, there was just 7 numbers. So I can come over here next. You can physically, put in numbers into the cell just like you can in Excel. So I'm going to say, I could type 40, but I'm actually going to say A8 because that's the address for that cell. So I'm going to type A8 divided by 7. And let's see what it says for 8 divided by 7, 5.71, which is that number right there. Actually, it kind of bugs me that the default for some reason is only show 2 decimals in here. And I want to show a little bit more. So you don't have to have the students do this, but I like to have it at least match up to what we can see here. So to change that preferences, you're going to come over here to these 3 lines and go Options, and up here to Rounding, and let's go to 5 decimal places. Voila. All right. So let me just close out by clicking that again. Oop. All right. So 5.71429, all right, so it's the exact same. And notice that it actually increased the statistics chart by 5 decimal places, too. All right, let's do one more calculation on our spreadsheet here. And I'm doing this just to point out that not everything is going to exactly match the formula in the book. So here it's saying the standard deviation of x is 3.98808. So that's actually the sample standard deviation. It's not the population standard deviation, which is unfortunately the formula that the book gives, which is unrealistic for most cases. The book has you divide by n instead of by n minus 1. So, but let me just show you that it matches up. Let me scoot our frames a little bit. So I'm going to be able to see another column now. All right. So let's come over here and actually manually compute the standard deviation. So even though it tells us it's 3.98808, let's kind of do it by hand. So remember, the standard deviation is the you sum up the squares of the differences between each x and the mean, divide by 1 less than the number of numbers you have, and then take the square root. So I'm just going to focus on my x's right here. Oop, there's my x's. So just like you can in Excel, I'll go in column D and do it so it's not too jumbled up with all the numbers. So I'm going to come over here and say A1 minus, now I could type in this number by hand, but what if you make a mistake? So always better actually put the cell address. So I could do A9. The problem is if I type A9 right now, I want to always use A9, and if I do the whole dragging thing down like you do in Excel, it'll change that value every single time. So I need to make that A9 absolute. So if you know Excel, you put $signs in front, so it's the same thing here. All it's telling it is to always use A9. So, and then I'm going to square it, and that'll be good enough for now. All right, so I'm going to enlarge that column a little bit. All right, so it did 1, take away 5.7, blah, 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 and then squared that number. And I'm just going to drag this down so it does it for all of them. My 7 points, so there we go. And just to verify, if I just click on one, you have to double click. So it's doing A6 take away, and it's still A9 squared. I'm looking at right here. If I hadn't put that $signs in front, it would have changed the A9 to A10, A11, like that. But all right, so that right there is the squares of the differences from the mean, and then I want to sum all those up, so I'll use our sum command again. So adding those up ends up to be that 95-point number. And now here's where it's a little bit different from the book. So so that's currently stored in D8. So the book would have you divide by 7, but in reality you want to divide by 6. When I say in reality, I mean when you're computing the sample mean, which is the default in most statistical applications. And then we need to take the square root of that number. So square root of what we just put into D9. And notice it says 3.98808, which is the exact same number we got on our little statistics chart right there. So that was just a little verification that these numbers are actually correct. So it tells you the mean of the x's and the y's. It gives you the standard deviation of x and y. It also gives you the r, and this is the part that we were sort of most interested in. Or instead of correlation, I know Adrian likes to look at the coefficient of determination, which is the r squared. All these other things, the rho and the square of the standard error, those are more statistical stuff. The kids can get into that in AP Stats if they like, but this is good enough for now. So if you want to access the R, you can get to it from here. All right, let me collapse the... So let me collapse it. A fast way to collapse the statistics screen is just to toggle this button off. does that. There's other, I'll let you play with it on your own, but there's other things you can do as well than just show the statistic stuff. But let's just focus on our scatter plot for now, because I want to show that you can do other models. So here's the linear model. Let's try a polynomial model. Oops. So you can choose different degrees. So there's degree 2, so there's a parabola, and it gives you the equation down here, the cubic, etc., etc. So, oops. So notice it's now letting me do 7. I didn't have enough points for that. So actually I think the most I can do is probably 6, right? Yeah. All right. All right, so that's polynomial models. Let's take a look at a log model. So there you go for that. Notice it's based on natural log. If you do exponential model, it'll base it on e. Now, if you don't want the kids to do e, you can actually change it to be a growth model. It will be exactly the same function, but instead of doing an e, it does e to the 0.0778 or whatever that number is right there, and rewrites it as a times b to the x instead of e to the x. But notice it's the exact same function, right, between growth and exponential. The graph didn't change. You can also do sinusoidal regression and logistic regression. So, all right, let's go back to the linear model. Whoa. And there's just one other cool thing you can do with this that I want to show you. You don't have to do this with the kids, but I think it sort of demonstrates something neat. So if we come back over here to the spreadsheet and highlight our numbers, and go over here and push this button right here. So it kind of looks like an ordered pair. This lets us create a list of points. So I'm going to do that. And it gives you a choice of calling it dependent objects or free objects. I'm going to choose free objects. And notice again, here's the thing that lets you switch around the x and y if you want. And go ahead and hit create. And you're like, okay, what did this do? Well, let me show you what it did. Let me open up this other window right here. This is in the middle frame. And click on it. And I'm going to adjust the window a little bit. Down so we can see all our points. I'm using the mouse wheel to scroll. You can also grab the individual x-axis and y-axis. And this is just much easier than the calculator, right? So on the calculator, you have to adjust your windows and so forth. And here is just a pretty simple matter of just pointing and clicking and dragging and so forth. Okay. So here's the neat thing you can do. Actually, I'm going to adjust so you can see this in the scatter plot at the same time. I changed my mind on that. Let me scoot this a little bit. Whoops. Scoot this a little bit here. I should be able to see both at the same time, so that means I have to readjust over here. I want you to be able to see all the points. Do we see everything? Yeah, there's one more there. Okay. Well, what's the point here? You can actually make the line show up over here too. You have to do that. You have to actually physically type something on the keyboard, and I don't want to go through that right now. So we'll look on this to see the points in the line. What I want to show you here is by creating that list of points like we did, you can now adjust the points and see these things move. So let's go over here. You have to click on this. This is the move mode. And I'm just going to grab a point right here. So this is the B point, which would be this one right here. And go ahead and try to watch it on the screen and watch it. This is the point 3,8. This is the second one. And it dynamically changes both on the graph here, and it's not only is it moving the point, it's moving the LSRL, and you can see the equation over here move, and you can actually see the numbers change over here. So I think that's kind of cool. You can do these experiments. And if you actually wanted to see the R-squared change, you could even turn on your statistics. And you're going to see here, as I change the B, it also updates the mean. And so everything is nice and dynamic like that. So, all right. Well, that's about it. That's making regression on GeoGebra.